this video, I'm going to show you how to import your files from other systems, vendors, and give you a jumpstart on your next design. So if you're like most new Fusion users, you probably dove right into the File menu looking for Import or Open options there. We don't have that, but the next closest thing is New Design from File. When you click this, you're taken to an Open dialog, but it can be somewhat misleading. Why? Because using this method only lets you bring in IGES files, Parasolid, Step, and of course Fusion files. But what about when you want to bring in other files, such as the grayed out SOLIDWORKS files you see here? For those, we need to approach it in another way. Let's access the data panel, where this washer has now been saved. If I click Upload here, I now have the ability to bring in files from Alias, Inventor, CATIA, NX, ProE, Rhino, SketchUp, and the reason I'm here, to bring in that SOLIDWORKS design. In addition, you can store your rendered images here, Word documents, PDFs, and so much more. To import this SOLIDWORKS design, I'll select the assembly file and all the referenced part files. Had there been other assemblies or subassemblies, this dialog would have been intelligent enough to ask which was the master assembly. When I click Upload, the file conversion starts. And in no time at all, it'll be ready for use in Fusion 360 for those simulations, renderings, CNC toolpaths, and of course, for design work or modifications. We'll open the file now and hide the data panel. Next, I'll add a couple appearances to make this look more realistic. Hitting A on the keyboard is a shortcut to access these options. Once I find a color or finish, I'll just click and drag it to the component or faces. Make sure to search for what you want, and if you find something that isn't already in the extensive database, more are always downloadable. One thing that'll need to be redefined in Fusion 360 are the mechanics of the system. Before I go to define this, I'll tell Fusion 360 to capture the history by right-clicking the top-level name in the browser and selecting Capture Design History. At the bottom of the screen, I'll now be able to see the timeline where design changes will be captured. When I click and drag on the handle, you'll see nothing is restraining it from translating away. To resolve this and capture the proper mechanics, we'll use our efficient joint definitions, and further to that, because all the components are positioned properly in relation to one another, we'll use as-built joints. To get it back to where it started, I'll either undo the move with a Ctrl or Command Z, or use the revert button that appeared after the move. For those as-built joints I mentioned, I'll hit Shift J to enact the command, select the two components, then define the movement. In this case, the handle is tied rigidly to the lever. An animation helps me comprehend what rigid means in this case. Next up, let's make the sliding movement between the plunger and the base. Shift J, select, and the rigid animation denotes the lack of proper movement. So let's change the type from rigid to slider. When I do so, an additional input is needed to define the direction it's free to slide in. For this, I can select an edge, or a cylindrical face will work. Now it animates the correct movement. With just 4 more joints, we were able to build the proper mechanics for this 5-part assembly. And this is the efficiency of joints, because instead of restraining a single degree of freedom, as you do with mates, you're allowing one. Next, let's use the imported washer in the assembly. I'll open the data panel to find it, then right mouse click and select to insert it into the design. This positions it in the center of the workspace, which isn't ideal, but will allow me to show you how to use a normal joint. First, I'll translate it out of the center to make selecting it easier. With that done, we'll access the joint command from either the menu or by hitting J on the keyboard. Because it's not positioned properly, I need to pay attention to where I select on the components I want to attach. From the washer, I can use this edge, and on the base, I can use this edge. Similar to as-built joints, I can address the type, but special to this is the ability to flip or offset depending on how the selection was merged together. This one needs to be flipped. Finally, for those nuts, bolts, or other hardware you might purchase, make sure to take advantage of the integrated McMaster-Carr library. Just find the part of interest, dig down to the CAD selection, and hit Save. This will add the part to your current design, and again you can use a joint to connect it properly. From there, a rectangular component pattern can fill the remaining connection points. I hope this import lesson has given you a jumpstart as you bring your design work over to Fusion 360.